Okay, guys, welcome. Today we're going to talk about writing certain equations in quadratic form. Now, there are some equations that we'll look at that may not look like a quadratic when we first analyze them, but we can make them more into a quadratic equation. So what we're going to do is basically what is going to drive this whole idea is if it's possible to take an equation and make it look like a quadratic, where this u is chosen appropriately to make this happen. And of course, if we can bring it into that form, we can use the methods that we've already talked about in order to, oops, don't know what happened there. We can use the methods that we have talked about in order, let's bring this back, to solve the resulting equation. So for example, just before we actually look at one, we could look at the example that's here, this 2 times x minus 3 squared plus 5 times x minus 3 minus 7 is equal to 0. Now, of course, it doesn't look like ax squared plus bx plus c is equal to 0, but it's sort of there, right? So what we're going to do is we're going to think of x minus 3 as some variable. Usually we choose it to be u, which then makes x minus 3 into u squared. So as long as we take u to be x minus 3, then we can write this equation here as 2 times x minus 3 squared, but that's u squared, plus 5 times x minus 3, which is what we chose to be u, minus 7 is equal to 0. So this is an example of an equation that can be brought to quadratic form. And here they're going to show sort of another derivation of what we just did here. So that's sort of the idea. And of course, we can know how to solve this. We could solve with either factoring if possible, or completing the square, or the quadratic formula. And then once you have solved that in terms of u, you can then use your original substitution for what u was to find out what it is in terms of x, or whatever your original variable was. So of course, there's some more examples here where even though it's not quite in quadratic form at first, it can be brought there by a suitable substitution. So for example, you have y to the 4th minus y squared minus 6 is equal to 0. If you choose u to be y squared, then it can be written in this form. And if you care to look at those examples a little bit more, you can pause it and review those. But we're just going to move on and we're going to do an example. So how do we solve an equation that we can make in quadratic form? Well, the first thing that you do, of course, is makes the substitution that will make that happen. And usually if it can be done in this way, whatever the middle term is, or the middle power coefficient, we'll say, is usually what you're going to make. Sorry, not the middle power coefficient, the middle power variable expression is usually what you're going to make. I don't know if that's definitely the right wording, the best wording for it, but that's sort of the idea. We want to make whatever is sort of the middle power. So in this case, your middle power is x to the 1/3. So that's what you would use as your substitution. So we're going to sort of do a similar thing there. Then once you make your substitution, you're going to solve that equation for u. And then like we mentioned before, plug back in for u, solve for the original variable. And of course, you should always check about looking for extraneous solutions, but really that's only going to come into play if you raise both sides of your equation in step 4 to an even power. So in that case, you might end up with some extraneous solutions, but let's take a look. Okay, so first, we have x to the 4th minus 13 times x squared plus 36 is equal to 0. Now, of course, this is not quadratic, so we can't treat it as a quadratic right away. But we see that we have our middle term here as x squared. So one thing that we might try, u is equal to x squared. Well, if u is equal to x squared, how could I represent x to the fourth in terms of u? Well, of course, if I square u, that's what we want to happen. And if we square u, that's x squared squared, which is x to the fourth. So since both of these powers match here, that's how we know that we can make this substitution. So now sort of our first step was all this stuff here, but now we can write the equation as u squared minus 13 times u plus 36 is equal to 0. So that's our first step. So now we want to solve this in terms of u. So if possible, we would like to try and factor it first. So we need two numbers that multiply to 36 and add to a negative 13. And of course, we can do that. We can say that this is u minus 9 and a u minus 4 is equal to 0. If we multiply negative 9 and negative 4, we get positive 36. If we add them, we get a negative 13. So of course, this will give us u is equal to 9 and u is equal to 4. So now, sort of step 3 is to now put this back. Well, what was u originally? We said that u was x squared. So we have x squared is equal to 9 and x squared is equal to 4. So now step 4, let me come up here so I don't run into the next example. Step 4 is to solve each of these. So if we solve x squared is equal to 9, that would be square root both sides, and you get x is equal to plus or minus 3. And of course, x squared is equal to 4 does something similar, except we get x is plus or minus 2. Now, I didn't raise both sides to an even power here, so I know that both of these answers for each equation are valid. So step 5, you don't need to check, but you can check if you want. Right, but these are going to be your 4 solutions for x. Okay, let's do another example. So now in example 3, we have something similar. We have 6 times x plus 1 squared minus 7 times x plus 1 minus 3. Now, of course, you could distribute everything out and you would arrive at another quadratic, but it's not clear if we could factor that or if we would need to do something else. We could complete square, maybe use quadratic formula. But for the sake of argument here, let's try substitution again. Try and bring it to quadratic form. So if I try this to be my u, so if we let u equal x plus 1, well then of course you can quickly see that if you square u, you just have x plus 1 squared, which of course does match this here. So now this says that we can write this in the form 6 times u squared minus 7 times u minus 3 is equal to 0. So let's try factoring this one. This will be a good review of the previous factoring method anyway. So here we have something in front of our u squared that's not 1, so we need to do our sort of our a times c factoring method. So in this case, a times c is 6 times negative 3, which is negative 18. And if I want two numbers that multiply to negative 18 and add to a negative 7, we could use negative 9 and a positive 2. So now at this point, we can rewrite our original equation, and let's put it this way. So we can say that it's 6u squared and minus 3 equals 0. None of that's going to change, but we can write minus 7u as minus 9u plus 2u. And now, of course, at this point, we could factor by grouping. So I can group my first two terms together. I can group my second two terms together, plus in between them, and factor each separately. So in the first expression, we can factor out a 3u. We'll get a 2u minus 3. And in the second one, I have what I want, so I'm just going to factor out a 1. And 2u minus 3 is equal to 0. So now we're going to get that 3u plus 1 times 2u minus 3 is equal to 0. So of course we get that u is equal to minus 1 over 3 from the first one, and we get u is equal to 3 over 2 from the second one. So now again, what was our original u? Well, our original u was x plus 1, so we now want to solve x plus 1 equals 3 over 2, and x plus 1 equals minus 1/3. Well, on this one, if we subtract 1 from both sides, we get that x is equal to 1 over 2, right? If you find a common denominator, you'll find that x is 1 over 2 there. And in this one, if we subtract 1, you'll find that x is equal to negative 4 over 3. And again, here we did not raise both sides of this equation to an even power, so I know that both of these answers are good. So both are valid. And you can check on your own if you would like as well. Okay, so let's do one more example of this, and that will wrap up this video on solving quadratic equations, or solving equations that can be brought to quadratic form, I should say. Okay, so one last example. Again, we can try and let u be x to the minus 1, and it may be helpful to note here later that what does x to the minus 1 means? It really means 1 over x. Now, of course, if we square u, that's x to the negative 1 all squared, which is x to the negative 2. So that is this here, and u is that there. So we can now write this as 0 is equal to 4 times u squared minus 9 times x to the minus 1, which is just u, and then plus 2. Okay, so now, of course, we can solve this, and we'll do the AC method again. So a times c is equal to a positive 8, and two numbers that multiply to a positive 8 and add to a negative 9 would be negative 1 and negative 8. So we can write this as 0 is equal to 4u squared minus u minus 8u plus 2 is equal to 0. Oh, I already have my 0 in the beginning. So let's just factor by grouping and put a plus in between the two there. So it looks like in my first pair, we can factor out a u. So we'll get u times 4u minus 1. And in the second pair, it looks like I can factor out a minus 2 if I want these two things to match, and I'll get a 4u minus 1. So it looks like we can factor this as u is equal to u minus 2 times a 4u minus 1. So the first one will give us u minus 2 is equal to 0, which is u equal to 2. And this one, in a similar way, will give us u is equal to 1 over 4. Okay, so again, last but not least, u was equal to 1 over x. So we could say that 1 over x is equal to 1 over 4, and 1 over x is equal to 2. Now, if you cross multiply here, you'll get right away that x is equal to 4. So that's one answer. If you cross multiply here, if we think of 2 as 2 over 1, we'll get a 2x is equal to 1. So then divided by 2 will give us x is equal to 1/2. All right. So, and again, we did not raise both sides to an even power here. So both of these answers are valid. All right. So that wraps up this video on solving quadratic equations, or again, equations that can be brought to quadratic form. So I hope you enjoyed, and I will see you next time.